Years of R&D and professional experience in civil and structural engineering, leading projects in advanced concrete technology, corrosion assessment, solid waste management, and climate resilient buildings. He had published various publications and notable contributions. Thank you. Now our chief guest will deliver the address and sharing his knowledge. I will welcome you, sir.
Thank you, madam. Thank you. Thank you. Is my screen is visible?
Sir, yes, sir. It is visible, sir.
Yes, shall I proceed, sir?
Sir, yes, sir. We can continue, sir. Thank you, sir.
So, today we are going to talk about AI tools applications in sustainability and risk assessment of natural disasters. So, this is a faculty development program. I thank the management of University College of Engineering, Dindigul, principal sir, and then HOD madam, then organizers, then other coordinators of this faculty development program, Divya madam, everyone. Thank you for giving this opportunity to talk on this special topic called AI tools applications in sustainability and risk assessment of natural disasters. So about me, so presently I'm working as a principal scientist in CSIR Northeast Institute of Science and Technology. So basically, our institute was established in 1961. So we have pioneered in various fields, including engineering, science, and technology. So we have multiple area called agrotechnology, chemical engineering, pharmaceuticals, cement, petrochemicals, environmental. So these are all about our institute, about our division. So majorly we have two groups, applied civil engineering and mechanical engineering group. And concerned about civil engineering, we are basically working in structural construction technology, building materials, structural health monitoring, geotechnical and transportation engineering. So our majorly running research project is 3D printed construction contribution to national projects, the resilient buildings, then energy access in SCST dominant areas, in-house initiatives like the dominant area in the west coming district of Arunachal Pradesh, and in-house initiatives like sustainable solid waste management aligned with circular economy principles. So this is about our brief introduction about our institute. So then risk assessment of natural disasters. So first of all, identification of natural hazards. So for what is in a natural hazard? So identification of natural hazards. So natural disasters may vary by geography, environment, and common hazards are geological, hydrological, meteorological, biological, and environmental. So in northeast region, we face earthquake, landslides, and flood. So these are the major issues in northeast region. In Tamil Nadu, we encounter flash floods in the city regions, then drought in the interior regions of Tamil Nadu, and in coastal regions sometimes we encounter rarely. In 2004 we encountered tsunamis. So these are all the major natural hazards. Then hydrological hazards means floods and storm surges, flash floods. Meteorological hazards includes cyclones, the blizzards, heat waves, droughts. These are all the things. Then environmental means wildfire epidemics like COVID and then followed by this black fungus. So these are all the biological hazards. So these needs to be assessed. So how do we assess? What is the framework? How do we assess these risks? So first thing is probability, likelihood of occurrence, high, medium, and low. So how do we come to a conclusion based on our previous data? So for anything, we have to quantify the materials actually. So how do we, for example, we are constructing a house, but we pay. How do we pay? By based on the quantities. So we have to quantify the things. So daily works, how much work has been completed? Excavation, how much quantity has been completed? Then brickwork, then plastering, how much quantity per day one person has completed, the contractor has completed. Based on that, payments are made. So this is how the risk assessment also there is a close relationship with this. We have to assess or we have to quantify the materials. So for that, how these AI tools are helpful, so that we are going to see. First thing is probability, then frequency. Frequency means whether it is coming again and again and again, or it is rarely it is coming. So when tsunami came in 2004, only one time in the whole of our nearly every 50 nearly of 50 to 100 years, only one tsunami has come. But at the same time, in northeast region, floods come very frequently. Means every year it's flooding. So it's about the probability, then frequency, then severity and the impact. So potential consequences like loss of life, then loss of life, economic damage, and environmental degradation. So we have to assess every year. We have to assess how many life has been lost for the natural hazards and for the man-made hazards and for the environmental, ecological, biological, and these for these different hazards, and how many amount of economic damage has been done, how much land loss has been done, land loss, and how much material loss. All these things needs to be assessed. The exposure, population density, infrastructure, and assets in hazard-prone areas. So, how much area is exposed for these hazards? So, for example, the wildfire. So, how much area the wildfire has been um, spread, and what is the consequence of it? Then how much amount of infrastructure has been damaged due to this wildfire? So this needs to be assessed in the hazard analysis. Then vulnerability assessment. What is in the vulnerability? So likely it will get the chances of getting affected. So physical, social, economic, and environmental. So these are the four major category for vulnerability assessment. So physical, the quality of buildings, infrastructure, resilience. These things are the vulnerability assessment. So majorly earthquake vulnerability assessment means we used to go to the site and we see the site, and then we found whether cracks are whether cracks are there or not. Then whether deterioration is due to corrosion, or whether the deterioration is due to the prolonged sustained loading. What is the reason for this? So then first, just going to the site and measuring the taking photographs and visual observation, if we report it, that itself a virtual assessment. So that's called vulnerability assessment. Then at the damaged site, if you go and if you evaluate, so for these things, that AI tools will be very helpful. So we are doing structural stability certification. We are giving for Airport Authority of India, then power grids, then various school buildings. We are giving stability certificate. So for this assessment, first thing is physical assessment. So for this physical assessment, AI tools are extremely helpful. So first you have to go there and you have to take the photograph and just upload it, and we can access it. So using our correct prompts are very important. So whatever suggestion, whatever the point you are giving, AI don't have the ability to think on its own, but we have to give the correct prompts. Correct prompts will give the correct results. So just upload the figures in the ChatGPT or OpenAI or Gemini, DeepSync, or any of the sites, and just upload it and give correct prompt. Analyze the crack, analyze the dimensions, analyze these things, whether bracings are horizontal bracing, vertical bracings, whether all these things are okay or not. all these things can be assessed. So AI will not, even human can do error, AI will not do error in this case if correct prompts are given. So then social vulnerability assessment, poverty, education levels, awareness, and preparedness. Then economic assessment, the economic assessment dependency of agriculture. For example, a natural hazard has come, and the complete agriculture is devastated by this natural hazard, like flood and other things. Then tourism, how the if there is a man-made hazard, then what is the effect on the tourism? All these things needs to be evaluated. Industry sensitive areas to be disasters. So all this, how much amount of total, we have to arrive with the figures actually. So these are all physical phenomenon. Flood is a physical phenomenon. Earthquake is a physical phenomenon, and we have to convert into a because of the earthquake there will be a loss and there will be damages in the buildings and there will be life loss. All these things are losses actually. These are all physical phenomena. We have to convert this into a mathematical quantity. So we have to convert into a mathematical quantity actually. So environmental, then degraded ecosystems, deforestation, poor land use planning. So this also a land use planning is a very important concept, which is a upgrading concept which we have to propose. Being a civil engineers, we have to work on land use planning. So in Anna University, where there is one course completely on this the mapping and the GIS and other things. Actually, they are all their their major work is to do land use planning. Then risk evaluation. Risk is nothing but hazard and exposure and vulnerability. So frequency of the hazards, high exposure, high vulnerability. So cyclones in coastal low income areas, then these has a high risk, medium risk, moderate frequency, or low exposure, low risk, rare hazards, strong resilience, and low exposure. So, for example, even there was flood. If we have a strong resilience, we are able to come back with our economy, or we have the proper planning. Then it is called low risk. If there is a moderate frequency or lower exposure, then it's called medium risk. Then risk levels. Yes, risk levels. So earthquakes, high risk in the tectonically active zones, northeast zone. The severity depends on the preparedness of the building codes. So we should have a proper plan or proper design, and for that full scale testings, full scale models needs to be carried out in the analysis, and then full scale testing. All these things needs to be essential for the earthquakes, portal preparations, and other things. Then floods, increasing risk worldwide due to the climate change and urbanization, high exposure in river basins and coastal regions, then high risk in tropical coastal zones, that's nearly Odisha. Then severity increases with the sea level rise. Then wildfires, high in hot, dry climates with extensive vegetation, brought severe impact on the agricultural dependent economies in the Africa and South Asia. So AI tools and applications, AI for hazard prediction and early warning. So machine learning models trained in historical disaster data, rainfall, seismic activity, wind patterns. So these are all very big work, and each team rainfall means exclusively the water resources engineers are working on it. Seismic activities completely work. This activities completely by the seismologists and earthquake engineers. Then wind patterns. So this is also done by structural engineers to forecast floods, earthquakes, and cyclones. The deep learning tools like RNN, CNN, LSTMs. These are the deep learning models. We have a good amount of data is generated. That the data are used for this for prediction, for forecasting the weathers and flood risks. All these things, this deep learning is useful. So Google AI flood forecasting predicts the riverine floods and hydrological and machine learning models, ML models. IBM Watson AI for disaster prediction. uses weather plus satellite data to anticipate storm and wildfires. So these are all the physical phenomenon. The flood is a physical phenomenon. Storms, wildfires, these are all the physical phenomenon. And based on the existing data, based on the existing data means for floods, we have the river basin, the depth of the flood, and the height of the flood, and the quantity of water discharge, and all these things are the parameters. Based on the parameters, we could able to predict the future. We could able to predict the future of the future forecasting of these natural disasters. Then AI for vulnerability and risk mapping. So geospatial AI, that is Geo AI, combines the satellite imagery, remote sensing AI to map landslide prawns, plains, and coastal risks. So these are all the geospatial AI computer vision models for detect deforestation, soil erosion, and urban sprawl from the satellite images to assess the vulnerability. So how many? I hope many of you are using this Photoshops, using AI models nowadays. It is quite easy. Earlier, if you are using Photoshop since 2016, you could able to see the difference in 2020, 2024 models. You could able to do the things very easily with a lot of picture enhancement, and that we could not able to find which one is real and which one is fake. So such a nice Photoshop models are coming up. We could able to edit, we could able to figure out, and we could able to correct the noises. So these are all the advantages of this AI models. So nowadays AI is linked with the videos, which could able to predict the elephant crossing, then which could able to find the trespassers, which could have a for example in Kaziranga National Park, there to monitor the elephants crossing, they have fixed AI thermal based videography, and also to cover the poaching. So when there was poaching, or the strangers enter into the animal zone, the concerned authorities will get the alert. So when the elephants are trying to cross the railway lines, so that time we get the alerts. So this is how the AI system works, and it gives a proper alerts. So direct deforestation, soil erosion, urban sprawl. So these are all other things that the natural disasters can be assessed actually. So other Google Earth Engine plus AI for monitoring the environmental degradation, GIS data for disaster prone area classification. So these are the AI tools applications actually. So AI tools and applications, AI for real time disaster monitoring. So IoT means IoT plus AI, that is sensors networks combines with AI detects earthquakes, so water levels and water fire spread. For example, railways or some of the bridges which is constructed of greater height, Chenab Bridge and other bridges are continuously monitored actually. So there we have placed the sensors to measure the continuously measure the strain or deformation. So first we will measure the deformation, that will be converted into strain, and the strain to stress, then stress to force, and what is the force acting on this structure, whether it is the member sections are sufficient or not. So that we are checking using this sensor networks. And now this data, for example, we are monitoring the um, we are monitoring the temperature and humidity of existing bamboo buildings. So that bamboo buildings could able to we could able to monitor the for continuously for more than 1 year. So huge volume of data is generated, but AI has the capacity to tell or detect the find faults in the huge amount of data. For example, we have 10,000 data points out generated out of 8 sensors per day. Just imagine the volume of data has been generated, and our Excel sheets or this MATLAB are not sufficient to bear such a big calculation models. And when we try to propose some equations, all these things are facing difficult. We are facing difficulty out of it. So there, these AI models, AI tools are very helpful to detect the issues, to detect the flaws, and to rearrange the system. So all these things, these AI tools are extremely helpful. So then AI for post-disaster damage assessment. So anything, as I said earlier, assessment is very, very essential. Anything needs to be assessed. So quantitatively, we have to propose policymakers. So stakeholders, who are on stakeholders, district collectors, Tahsildar, these revenue inspectors. These are all these people are stakeholders, and they are policymakers. Politicians are policymakers and stakeholders. We have to, being a researcher, we have to educate them with the proper data. So what is our role? Our role is very specific, and we have to generate the information. We have to quantify the assessment. So what is the in this post disaster damage assessment? These AI tools are very useful. Drone based AI, then crowdsourced AI analytics. So what they will do, the image recognition models assesses the buildings and infrastructure damages. So, for example, if there was a if there is a earthquake, and or there is a flood, or there is a hurricane, wind, then in those cases, after the disaster, um, by clicking a nice photographs, so this will give a quantitative clear priorly how the image was, and after the flood and other things, how the image is. So this way it compares, and it gives the proper data about the damages caused. Then AI tools and applications, the decision support system, AI powered risk simulation, scenario of modeling for disaster preparedness and resource allocation, then multi hazard risk platforms, integration, different AI models to composite the risk analysis, compute the risk analysis. So that this inventor AI enhanced platforms use the UNDP for disaster risk reduction, and open AI models like GPT or geospatial data assist in interpreting the disaster risk and generating preparedness plans. Then, then mix these AI tools for um, uh, sustainability. So, in my topic, not only restricted to the disaster assessment, it also covers the topic called sustainability. So, sustainability means mixed design optimization, machine learning, ML tool, deep learning models are useful. So, reduce the cement usage, then main source of carbon dioxide emissions, improve strength, durability, and workability. These are all improved with these things. And tools versus platforms, the MATLAB plus MI tools, that is machine learning tools. We have artificial neural network, ANN, CNN, RNN. So these are all the uh, applications of this machine learning toolboxes. So these are, I hope, in faculty development program, mostly all our faculties are PhD scholars or MTech students. So you should compulsorily learn this MATLAB toolboxes, which are very easy to um, predict the uh, information. For example, that compressive strength of cubes can be predicted with the existing data points. So for that, MATLAB plus toolboxes are sufficient. So it is like Excel only. You don't have to fear that, no, I have to write a big codes, or how I can do this. So you don't have to write codes. So nowadays in ChatGPT, you can able to generate codes also to run in the MATLAB, to run in the Python and other things. So at least if not that codal level, so it's very easy to use as a toolbox, machine learning toolbox for predicting the modeling. And TensorFlow or Python models, then genetic algorithms and neural networks, that is on RNN, ANN, CNN. These are all the neural networks which has a multiple objective optimization. Then performance prediction and life cycle analysis. AI regression models predict the compressive strength, the durability, shrinkage of sustainable concretes. Then life cycle assessment. integrated with the AI to evaluate the environmental impact from production to demolition. This is called life cycle assessment. Then tools that machine learning for based strength prediction, but to simulate the embodied carbon across the project stages. Nowadays, the advanced topic is carbon capture. So AI plus BIM could able to capture the carbon quantity of the carbon utilized for these things. Then AI tools for sustainability. So waste and alternative materials like the slag, then silica fume, then ashes, all these things can be used. So these things you can come up with the rational proportions with these AI tools. So AI powered material selection incorporate the industrial byproducts like fly ash, slag, recycled aggregates, plastic waste in concrete mixes without compromising the strength. Then computer vision models classify this automated, this machine learning, Google ML, that OpenCV for automated visual quality inspection of aggregates. Then structural health monitoring. So that is also I explained in the AI plus IoT sensors embedded in concrete structure detects the cracks, corrosion, and stresses early, extending the lifespan and reducing the replacement needs. Predictive maintenance models for anticipate the failure risks, tools and platforms. So deep learning CNN could able to detect the crack detection and the crack propagation, rate of crack propagation. All these things can be assessed using this deep learning models. AI tools for sustainability, of course, the carbon footprint reduction and circular economy, AI-driven supply chain optimization to minimize the emissions from civil production and transportation, carbon capture in concrete AI models to simulate carbon dioxide absorption in curing and recycling phases, actually. So structural failures in buildings and bridges using detecting the structural failures in buildings and bridges using this AIs. Structural failure occurs in building or bridges, losses inability and its ability to carry the load safely, leading to partial or total collapse. The causes include poor design, material defects, natural disasters, construction errors, aging. So these are all factors for the failure of the structure. AI is now helping in the early detection and the prevention of such failures. Actually, common causes of structural failures in buildings are design errors. Of course, structural engineers, if inadequate load calculation, poor seismic design, poor detailing, all these things comes under these design errors. Then material failure, for example, low quality concrete, corrosion of steel reinforcement, not providing enough covers, cover depth, not providing enough foundation, all these things, enough depth, all these things. For example, minimum M30 grade of concrete is given, but you have provided only M20. In those cases, failure may occur. So these are all the cases, and minimum, for example, minimum is FE 500, but in these places FE 415 is given. So in those cases, there will be failures. Then the foundation issues, soil settlement, liquefaction in earthquakes, and other issues like in airport authority, airport pavements, there is enough CBR value is not there, but however the pavements are made, those cases foundation issues will come. Then overloading, then unauthorized modifications, excessive loads. For example, it is designed for certain loads for 2000 kilonewton, columns are designed for 2000 kilonewton. So, but the actual loads are more than that because of the excessive loads or unauthorized modifications. All these things leads to overloading, poor workmanship, improper curing of concrete, weak joints, more amount of natural hazards, earthquakes, floods, cyclones, and fires. These are the reasons for the structural failures in the buildings and bridges. Then fatigue, and then in bridges, fatigue and aging, of course, low cycle fatigue uh, in railways. You could able to see the railways with the low cycles and high cycle, low frequency and high frequency, high speed, low speed. All this type of fatigue is there. Then aging is there. So recently we could able to see common bridge is replaced with the new bridge. So a huge amount of money has been pumped for this transportation of railways. So age is also a significant factor. So their steel fatigue, corrosion, and concrete deterioration. So in our lab, we could able to see the corrosion, which is significant. As our institute is more than 60 years old, so here we could able to see corrosion is a big issue. So once we break the concrete, we could able to see out of 10 bars, only 2 or 1 is left. Remaining all the reinforcement has been corroded. So age and corrosion has a significant role in the failure, overloading, exceeding design vehicle weight limits. All these things has been issues. Then scoring, riverbed erosion, undermining the foundations. For example, one building is in the city side. We could able to see one building is nicely constructed and completed and occupied, and the next person will start the building works, and he want to give a nice foundation. So he will give foundation which is more depth than the existing building. For example, the neighborhood person constructed with 5 meter depth, then he wants to go for some 10-meter depth. So in that cases, that issue will come. That is undermining the foundations. This is a very serious issue. The seismic forces, then earthquake-induced vibrations causing cracks and collapse. Then design construction errors, inadequate reinforcement, poor welding, then insufficient quality of reinforcement provided. All these things are the errors. Lack of maintenance. These also causes the issue. So if the bearing pads and the bearing, all these things are not properly provided, it failures. If the cracks are not uh, found on time, then this leads to the failure of the bridges. Then examples of structural failures. There was a Rana Plaza collapse in Bangladesh, where poor construction and overloading leads to more than 1,100 deaths. Then Miami condo collapse in USA, which is a long-term corrosion and structural deterioration. So even though there was multiple mechanisms to monitor the quality of the bridges, so buildings, so this collapse has been seen. Then bridges, Morandi Bridge in Italy collapsed due to corrosion of cables and poor maintenance. So poor maintenance, you could able to see the maintenance is a serious issue here. Then Kolkata flyover collapsed in 2016. Poor design plus weak materials. Then the quantity, if the as I said earlier, the concrete quality should be poor, the grade should be properly fixed. Then failure modes are cracking, buckling, shear failure, fatigue failure, and progressive collapse. So these are all the failure modes which if you are a forensic civil engineer, first and foremost thing you have to monitor is what type of cracking is there. Concrete is due to stress, temperature, shrinkage, or overloading. What kind of crack is this? Then buckling, whether it is failed due to buckling or not. Columns or girders bending under compression. Then shear failure, the crack of the building size, the inclined cracks, that is 45-degree crack can be seen, able to see. So here the failure is catastrophic. If it is a shear failure, the failure should be a catastrophic. Fatigue failure, repeated stress cycles in steel. Then failure triggers chain reaction actually. Then role of AI in preventing the structural failures. So computer vision, it detects cracks, corrosion, spalling of concrete using CNN models. So if you could able to take the photograph and upload in the chat GPT or any other thing, and if you could able to properly give the proper prompt to find the diameters, it properly tells there is a defect, and whether defect is there or not, it properly guides us. Then drone plus AI inspection for bridges and high-rise buildings. Then predictive maintenance, machine learning on sensor data, that is strain gauges, vibration, displacement sensors, predicts failure before the collapse. Then IoT, then AI systems detect the unusual stress loads and temperature variations. The digital twin technology, AI-powered digital replicas of buildings or bridges to stimulate the stresses and aging. Of course, finite element models are nowadays very easy to model, and we have enough computational capacity also to do such big analysis, predicts how the structures behave under the different loads and hazards, and analyzing inspection and reports and maintenance logs to find the hidden failure patterns. So natural language processing. So benefits of AI-based structural failure analysis: early detection of hidden defects, reduced inspection cost, drones plus AI instead of manual teams. So manual team means, just imagine a Kaziranga National Park is such a big national park. It's impossible to monitor all the places. So AI has the capacity to cover a big level, wide range. So that's how the drones plus AI has the capacity to monitor in a bigger level in the borders also. Nowadays in army defense, the borders are monitored with this AI supported drones and cameras. Increased safety for public and workers, extends lifespan of structures, supports smart city and resilient infrastructure. So these are all I have explained about the applications, and I want to give a detailed explanation about AI tool in the optimization of mixed proportioning of concrete. So how? So I before that I explained this the mixed proportion. Before that, I explained the mixed proportioning of concrete. So I have to give a detailed description about this. So this will help you to do a consultancy also for you. So first you have to understand the concepts. Based on that, you can able to uh, do the same thing in AI tools. So grade designation, type of cement, maximum nominal size of aggregate, minimum cement content, maximum water cement ratio, workability, exposure conditions. Then data for mixed proportioning, maximum temperature of concrete at the time of madam, another person is also operating. Please. Madam, is it audible?
Sir, yes, sir. Audible, sir.
Yes, sir, audible.
Another person, actually, another person is also operating. He's closing this. Who is the host?
Sir, tell me, sir. Hello.
Yes, madam. Actually,
Sir,
when I am operating parallelly, another person is also operating. That's why slides are moving here and there.
sir, okay, sir. I will see, sir. Okay, sir.
Yeah.
Fine. Wow.
Okay, I will proceed now. So, so the grade designation, type of cement, maximum nominal size of aggregate, minimum cement content, then maximum temperature, minimum cement content, maximum water cement ratio, workability, exposure conditions, table 4 and 5 of IS 456 2000, minimum then maximum temperature of concrete at the time of placing, method of transportation, and spacing, placing. So here the grade designation, type of cement, maximum nominal size of aggregate, minimum cement content, Sir, please check that some other host please don't operate. Then since I am operating. Sir, check பண்ணுங்களேன் இன்னொரு
சார் இல்ல சார் கரெக்டா தான் சார் இருக்கு சார். யாருமே வேற யாரும் லைன்ல இல்ல சார்.
இல்ல
ஆமாங்க
நான்
சார்.
வந்து என்னோட ஸ்லைட் வந்து ரன் பண்ணிட்டு இருக்கும்போது இன்னொரு அது ஸ்லைட் போயிட்டே இருக்கு. நான் ப்ரெசென்ட் பண்ண முன்னாடியே செக் மாறிட்டு இருக்குது. அதுக்கப்புறம் கர்சர் வந்து நான் யூஸ் பண்ணாத கர்சர் வருது.
இல்ல சார் நீங்க ஸ்கிரீன் ஷேரிங் வந்து நீங்க மட்டும் தான் சார் பண்றீங்க சார். இந்த
இல்ல இப்ப
பாத்துறேங்க.
நான் ஆப்ரேட் பண்ணாமலே ஸ்கிரீன் மூவ் ஆகுது. அந்த இது
அப்படி
நீங்க
இல்ல உங்க
ஷேரிங்
கர்சர்
டிசேபிள் பண்ணிட்டு
இதுல
திருப்பி எனேபிள் பண்ணீங்கன்னா சரியாயிரும் சார்.
இல்ல சார்
வேற
வேற யாரும் இல்ல
இடையில
சார்.
அக்சஸ் கேட்டிருப்பாங்க சார்.
இல்ல சார் யாரும் இல்ல சார்.
இல்ல நான் இந்த அப்புறம் என்னோட ஆப்ரேஷன் எல்லாமே ரன் ஸ்லைட் மூவ் ஆயிட்டு இருக்கு.
எக்ஸ்கியூஸ் மீ சார். சார் நீங்க டிசேபிள் பண்ணிட்டு திருப்பி பிரசன்டேஷன் ஸ்டார்ட் பண்ணுங்க சார்.
சரி ஓகே. So the objective of this is not to train you how to do manual mix design. The objective is to train you how to do AI tools to do the mix design. So that's what the objective. But to understand that AI tools, to understand how to use these AI tools, you should know the basic concepts. So that's why I'm trying to explain this basic concept quickly. That the maximum temperature of the concrete at the time of placing is required to measure the workability, method of transportation and placing. So, for example, what is the mode of transportation of ready mix concrete (RMC)? Then early age strength requirements if required. Then type of aggregate, then maximum cement content, and whether on admixture. So whether an admixture is required or not, the conditions of use, then target strength for mixed proportioning, in order that not more than space. What is in the target mean strength? So target mean strength is nothing but FCK plus 1.65 into S. So sir, again somebody is operating, sir. Okay, I'll continue. FCK plus FC plus 1.65 into S. S is the standard deviation. So only 5% of data can be less than the characteristic strength. What is in this 5%? For example, if you test the 100 cubes For example, if you test the 100 cubes, if you test 100 cubes, only 5 cubes can be less than the only 5 cubes can be less than the characteristic strength. So if you test 50 cubes, only 2.5 cubes can be less than the characteristic strength. And if you test 10 cubes, so if you test only 3 cubes, none of the cubes can be less than the characteristic strength. So this is what target strength for mixed proportional. Then assumed standard deviation. So the assumed standard deviation, the proper storage of cement, wave batching of all materials, controlled addition of water, regular checking of all materials, aggregate grading and the moisture content, then regular checking of workability and strength. So these are all the conditions to declare a site is a good site condition. So good site condition. So for M10 to 15, the assumed standard deviation is 3.5. M20 to M25 standard deviation is 4, and for this M30 to M60 standard deviation is 5, and for M65 to 80 the standard deviation is 6. So if it is a fair site condition, you have to use +1 here, +1, +1, +1, and here this is the +1. So for to come to a conclusion of good site condition, you should have proper storage, weighing materials, and controlled addition of water, regular checking of all materials, aggregate grading, moisture content. So these are all the things essential. So proper storage of cement, then fine aggregate, coarse aggregate. In coarse aggregate as also 10 mm, 10 mm aggregates and 20 mm aggregates. The gradation should be within this range. So there is always a range. So within that range, it should come. That's called aggregate grading, fine aggregate grading, coarse aggregate grading. Then there are 4 conditions. That is oven dry condition, air dry condition, saturated surface dry condition, and wet condition. So oven dry condition, there is no moisture, so completely it is dry. Air dry means there is some moisture. Surface dry means all the pores are filled with water. That is called saturated surface dry condition. Wet condition means there is a free moisture. So this is called wet condition. So usually the somewhere in between the absorption capacity somewhere in between saturated surface dry condition and the warm dry condition. This is effective absorption. This is the surface moisture. For this surface moisture, we have correction factors. So slump value. So all of you know about this measuring the workability. So for self-compacting concrete, the slump is almost it collapses. The whole thing collapses. For roller compacted concrete, it is a 0 slump. So this is the slump value. So for very good means pumpable concrete, it should be more than this 100 mm slump. So cube compressive strength for high strength concrete, you have the alternative of 100 by 100 mm cubes. You can test it for normal strength concrete 150 mm cube strength. So for this is very important for how do we plot or how do we fix the characteristic strength when we have the good amount of compressive strength values. So this is serial number. The second column is compressive strength. The range is from 43 to 35 to 48 MPa. So 43, 48, 40, 38, 36, 39, 42, 45, 37, and 35. Then deviation, there are 20 samples. So out of these 20 samples, this is the mean value. 40.20 is the mean value. And how much with respect to 40.20, each value. So this is X. This is each value, how much it is deviating. So that is called deviation. Deviation square means nothing but this is 120 square. So for this thing 40.20 minus 39, so that is nothing but minus 1.20. Just you minus 1.20 whole square is 1.44. Then this part e power minus x minus mu the whole square divided by 2 sigma. So sigma is nothing but summation of variance x minus mu the whole square divided by n minus 1. And then square root of this value is nothing but the standard deviation. Then once your standard deviation is found, then we can find this variable term. So this is a constant term. That is 1 minus 1 divided by 1 divided by sigma square root of 2 pi is a constant term, and this is a variable term. And for each x value, you need this term, and this is constant, and this is variable. Variable. And then we can find the probability distribution function, that is f of x. Once the probability distribution function is done, then we can have this plot. So here the 20 samples, what does it mean? The probability distribution curve describes. So here 50% of data is there, 50% of data, and here 50% of data, 50% of data. So only 5% of data. What is the 5% of data? 5% of sample is nothing but there are 20 samples. 20 in the 5%, that is only one sample. One sample can be less than the characteristic strength. So this is a one sample which is less than the characteristic strength. So that is how this characteristic curve, probability distribution curve is built. Then a grade of concrete, for different grade of concrete 10 to 80 MPa. So this is a standard deviation 3.5 to 6 MPa. For good site condition, the target strength is 16 MPa to 90 MPa. For fair site condition, the target strength is 17 to 92 MPa. So this is 5 to 10 mm, 10 to 14 mm, 14 to 20 mm, and 20 mm aggregates looks like this. So selection of water content. For different sizes of maximum nominal size of aggregates 10, 20, and 40, the water content is selected. And after the water content is selected, it needs to be corrected for the slump value, and it should be corrected for the admixture dosage. For these two reasons, it needs to be corrected. And for every increase in 25 mm of slump, there should be an increase of 3%. So, for example, the 25 mm slump, that is 75 mm slump is fixed, then you have to multiply this 186 into 3 divided by 100, you will get 192. So this is how this 182 comes. And here the water content, slump, and size of the aggregate is similarly for 10 mm aggregates. This is for 20 mm aggregates. This is for 10 mm aggregates. So here also 3% increase every 25 mm. Every 25 mm increase in the slump, it leads to 3% increase in the slump value. So then interpolation, or of course all of you know about this interpolation formula. So if x1, x2, y1, y2 are your known variables, x and y are x known, when only y is unknown, then formula for y equal to y1 plus x minus x1 divided by y2 minus y1 divided by x2 minus x1. So for the given values of 0.5, 15, 1.5, 30, and 1, y is calculated as 13%. So this is how the interpolation works. Then adjusting the cement content from 0.5% to 1.5%. Then water reduction is applied as 15 to 30% as the water reduction can be applied. So then the three curves for OPC 33, OPC 43, and OPC 53, and for different for 28 days target strength. For example, your target strength is 48. So this is a 48 MPa. Then if you are having the OPC 43 grade, then your water cement ratio, that water by cement ratio equal to 0.35. So this is curve 1 and curve 2 and curve 3 for different OPC values, OPC 43, 33, 33, 43, and 53 MPa. So this is the IS code criteria for plain concrete and reinforced concrete. So for the mean plain concrete and reinforced concrete. So once again, I want to reiterate. So all these things I have to explain just to explain about the artificial intelligence tool, how to generate this. So just to understand this, these are all essential actually. So minimum cement content, mild, moderate, severe, and very severe and extreme conditions. There are two criteria. One is plain concrete, another one is reinforced concrete. For plain concrete, the cement content, minimum cement content increases from 220 to 280. But the maximum free water cement ratio decreases from 0.6 to 0.40, and the minimum grade of concrete increases from M15 to M25. At the same time, for reinforced concrete, the mild, medium, and the severe grade of concrete increases from M20 to M40. In extreme conditions like coastal areas, you have to go for minimum M40 grade of concrete, and cement content is minimum 360 kilogram per meter cube, and maximum water cement ratio is 0.40. So it is decreasing from 0.5 to 0.40. Then approximate air content is 1% of 1% is the approximate air content for different nominal size of aggregates, and entrapped air is 1%. So volume of the constituents of concrete, volume of cement, volume of mineral admixture, volume of fine aggregate, coarse aggregate, volume of water, volume of admixture. If you add everything, you will get a volume of concrete, mass of cement, mass of mineral admixture, mass of fine aggregate, mass of coarse aggregate, mass of water, mass of admixture. This is called mass of concrete. Then density of the material, volume of the material is equal to mass of the material divided by specific gravity in the 1000. This is called the volume of the material. How to arrive the volume of the cement? So VC, volume of the cement, is mass of the cement divided by specific gravity of the cement into 1000. And this is mineral admixture. Ma is nothing but mineral admixture. Ma divided by specific gravity of the mineral admixture into 1000. Mineral admixture can be anything: fly ash, silica fume, metakaolin, ground GGBS, and anything can be termed as mineral admixture. Then fine aggregate, coarse aggregate, water, and chemical admixture. So these are all the values, and fine aggregate plus coarse aggregate is total aggregate, and then cement plus mineral admixture is nothing but volume of cementitious materials. For fixed value of water cement ratio, water by cement ratio is nothing but 0.50. These values are given for different zones: zone 1, zone 2, zone 3, and zone 4. That is different fine aggregate. The coarse aggregate by total aggregate ratio. So this is nothing but CA by TA. TA is nothing but total aggregate. CA is nothing but total aggregate. CA is coarse aggregate. For maximum normal size of aggregate of 20 mm, and for zone 2 value 60, your CA by TA value is 0.62. So what is it mean? What is meant by this 0.62? That means 62% of total aggregate is coarse aggregate. Remaining 38% is fine aggregate. So and the code is telling that this is for 0.5 water cement ratio. If your water cement ratio is 0.36, your value is somewhere in between the 0.4 and the 0.36. In this case, you have to interpolate the value. So for every decrease of 0.05, there will be an increase of 0.01 value of CA by TA value. For every decrease of 0.05 in water cement ratio, there will be an increase of CA by TA of 0.01. So if it is the value is come in between this interpolation, in here you have to do the interpolation. Then adjustment of water, fine aggregate, and coarse aggregate in all are designed for saturated surface dry condition, but reality is totally different. Either it will be in dry condition or in wet condition. So you have excess moisture will be there. So in that case, what you have to do? So there is a condition: fine aggregate, coarse aggregate in dry condition, fine aggregate, coarse aggregate in wet condition. In these cases, you should have a correction factor. This is called correction factor. Water needs to be corrected. Water needs to be corrected by fine mass of coarse aggregate or fine aggregate in saturated surface condition divided by 1 plus P moisture divided by 100. And in this case, the whole term is divided, and here the whole term is multiplied actually. So for the mixed design report, if you are doing consultancy services, so these are all the report. These are all the things should be available in the report: period of testing, details of work, relevant test data, source of the course and fine aggregate, details of the trials to be conducted, recommended mixed proportion. All these things should be available in your report. So this is an illustrative example. So for M40 grade of concrete, type of cement is PPC, maximum normal size aggregate is 20 mm, and then the exposure condition is severe. Then as per table 4, 5, table 3 and 5, IS 456, you have to fix minimum cement content, water, maximum water content, minimum grade of concrete. So grade of concrete is already given. So minimum cement content and maximum water cement ratio needs to be fixed according to the table 5. Then workability is 75 mm. Then pumpable concrete or non-pumpable concrete, crushed aggregate. Then fly ash, of course, 50 kilogram per meter cube. Then chemical admixture is super plasticizer. Cement used is PPC, specific gravity is 2.88 for the PPC cement. Super plasticizer is the mineral admixture. Then specific gravity of coarse aggregate, fine aggregate in saturated surface condition, and for chemical admixture. Then water absorption is 0.5% and 0.5%, 1% for fine aggregate and 0.5% for coarse aggregate. Then cement, moisture content of aggregate. Then coarse aggregate, here the table gives the information that 60% is 10 mm aggregates and 40%, 60% is 20 mm aggregate and 40% is 10 mm aggregate. That was the information is given here. Then batching of batching of standard grades of concrete. Volume of concrete is equal to volume of cement plus fine aggregate plus coarse aggregate plus water plus admixture. Mass of concrete is equal to mass of cement plus mass of fine aggregate plus coarse aggregate plus water plus admixture. So this is the volume of the material is equal to mass of the material divided by specific gravity of the material in 1000. Sequence of mixed design calculation for standard grades. Calculation of target mean strength, find the volume of water, adjust water content for slump and mineral admixture dosage, find the volume of cement, find volumes of admixtures, and concrete, find the volume of aggregates, adjust the water content, fine and coarse aggregate for wet and dry conditions. So this is the M40 grade. So 40 plus, this is the standard deviation. This is the 4.25. 48.25 is the grade of concrete for good site condition. Then select the water content. Water content is selected as 186, and this needs to be corrected for slump value and the admixture dosage. For slump value, it is corrected to 192 kilogram per meter cube. Then for admixture dosage, it is corrected. It is 182, and slump value, size of the aggregate. Then it needs to be corrected for two corrections. Number one is for slump value, and number two is for admixture dosage. So for these two reasons, it is corrected. Volume of water is 0.148 meter cube. Then finding the volume of cement. So you will get the mass of the cement divided by specific gravity. You will get the volume of cement. So you get the volume of cement. Then subsequently, you have to find the mass of the admixture. So that is 1% of the cement content. So 1% of cement content is 4.12 kilogram per meter cube. Volume of the admixture is equal to 0.04 meter cube. And volume of concrete is equal to volume of concrete 1 meter cube. Air content is 1%. Then actual volume of concrete is equal to 0.099 meter cube, excluding the air content. Then finding the volume of aggregates. So first, we have to figure out which zone the sand is. Water by cementitious material is 0.36. Water by cementitious material is 0.50. Then this is the way, and here the grade of concrete is for maximum normal size of aggregate is 20, and here it is zone 2. Here you can even say 0.62. So your water cement ratio is 0.36. So somewhere comes it. So So your value is somewhere 0.36, somewhere comes here. So as I told earlier, so this needs to be interpolated, and you have to find the interpolated value, and subsequently you will get the CA by TA value. So based on that, you can find the volume of the material. So you know volume of cement, volume of water, you know volume of chemical admixture. No, only thing left over is total aggregate. So first total aggregate needs to be calculated, and the proportion needs to be found out. That 64% of the coarse aggregate total aggregate is coarse aggregate, 36% of the total aggregate is fine aggregate. Then mass of the aggregate, mass of the fine aggregate, mass of the coarse aggregate, and then volume of the fine aggregate, volume of the coarse aggregate is calculated as 0.45, 0.25, and 0.45 meter cube respectively. So final outcome is this: cement 412 meter cube, water 148 kilogram per meter cube, coarse aggregate 1233 kilogram per meter cube, fine aggregate 648 kilogram per meter cube, chemical admixture 1%, that is 4.124 kilogram per meter cube. So this is the volume check. When you add all the volume, it has to come around 0.99 meter cube, and if you add all the mass, it should come around 2,400 kilogram per kilogram. So this is how the check has been done. Then for corrections for dry and wet conditions, so here it is at a dry condition. So this needs to be subtracted. So once it is subtracted, you will get the corrected value for the fine aggregate is 6 kg and coarse aggregate is also 6 kg. This 12 kg needs to be added as water to the uh, uh, estimated water content. So your estimated water content is 148. So this needs to be added as 160 kilogram per meter cube, and the remaining place this needs to be subtracted. So this is the revised cement content. So cement content is 17%. Coarse aggregate plus fine aggregate. This already occupies 75% actually. Then chemical admixture 4.12 meter cube kilogram per meter cube, and water is 160 kilogram per meter cube. Now we can go for this time. So now the AI tool is coming into picture. So this is the outcome of the AI tool. So that is ChatGPT or Gemini, anything if you want to use. So my prompt is only one line. That is mixed design of M30 grade of concrete. My prompt is only one thing: mixed design. This is called a prompt. Mixed design of M30 grade of concrete. So once you are all the ingredients: cement, fine aggregate, coarse aggregate, water, admixture. Yes, okay, everything is correct. The target strength calculated for M30 grade of concrete, this standard deviation is 4. Actually, it is 5 MPa. So this is a mistake. So again, we have to correct it here. So this is 36 MPa it is showing. So this is not correct. This needs to be corrected. Then water cement ratio, what is the condition? We have not given severe or very severe. What is the exposure condition? We have not given. So it has might be assumed it as this thing, and the water cement ratio it has tentatively assumed between 0.45 to 0.50. If you have a fixed water cement ratio 0.36, 0.4, whatever it may be, you can give the water cement ratio. So lower water cement ratio, high strength, reduce the workability. So water cement ratio it has automatically taken as 0.45. Then once cement content for 20 to 25 mm coarse aggregate as 100 to 150 mm slump, minimum cement content is 320 based on the exposure condition. So cement is fixed as 400 kilogram per meter. So water content equal to water content, water equal to water cement ratio into cement, that is equal to 180 kilogram per meter cube. So this needs to be corrected actually. So selection of aggregate. So this also randomly selects maximum 20 mm aggregate, specific gravity 2.700, 2.8, fine aggregate 2.6 to 3.2. So this is not exactly as per IS code. So another prompt you have to give mixed design as per IS 10262 2019. So like this, the prompt needs to be given. So severe condition needs to be given. Exposure conditions. Exposure condition. Then water cement ratio is 0.5, 400. So no minimum and maximum check needs to be done. So minimum and maximum check needs to be done. Check needs to be done. The total volume of aggregate is equal to. So these are all calculations are correct. The assumed density, everything is correct. Then fine aggregate is all these things are correct. But as per IS 1026 to 2019, this prompt we have to give. Otherwise, it will give a random values. So these are all the mixed proportions, and this is a random value. Hence, it is okay. So once you add everything, it should come nearly 2400 kilogram per meter cube. So adherence to is mandatory. So these are all the suggestions given by the this chat GPT. So now I will explain only one chat GPT for this only I will give only one. Just 1 minute. I will just share my. So this is the AI tools, that is chat GPT. So now this is the prompt space. In the prompt space, I'm going to type um, mix design of concrete uh, mix design of concrete for that M40 grade of concrete as per IS 022 2019 and spec. Then exposure conditions, mild here. Then any other condition, if you're using fly ash mineral mixture, uh, percentage of then you have to restrict the chemical admixture dosage, no? Chemical mixture dosage, 1% of minimum of. Now it will nicely design the mix. Uh, So here you can see the assumptions. So M40 grade of concrete, standard deviation is 4 MPa, which is not correct. Standard deviation is 5 MPa. The target mean strength is part 46, is 48.25 MPa. It automatically assumed the cement grade. Then exposure condition is severe. The durability, this is important. Fly ash is 10% of the cement content. Then chemical admixture 1% of cement mass. Then maximum size of aggregate is 20 mm. It is automatically assumed. Zone 2 sand is automatically assumed. Then finest modulus, everything automatically assumed. Slump value is 75 mm. Then water by cementitious material, it was fixed as 0.40 as per IS 456, maximum for exposure condition. Then specific gravities of cement, fly ash, fine aggregates, and coarse aggregates are it assumed by itself. Air content 2%. The maximum air content is 1%. You have to fix. Then nominal automatically it assumed, not assumed, it is from the as per the codal provision. This 186 kilogram per meter cube. Percentage, this is correct. Then the percentage of coarse aggregate absolute volume is 2.6, that is 62%. Then round immediate values are sensibly constructed for this figure. So first target mean strength was selected, then water cement ratio was cementitious material was fixed 0.40. Then it is corrected for the slump value is corrected. And so then again, so this is for superplasticization, again it is corrected. Then for slump value it is corrected. Again, this is for corrected. Then calculate the total cementitious material, how much it is 395. Then because 10% of is fly ash, so in that case only cement content is 359, that is rounded to 360 kilogram per meter cube. So fly ash is 10%, that is 36 kilogram per meter cube. Volume of the total cementitious material is 396 kilogram per meter cube, close to 395. Rounding is acceptable. Chemical admixture dosage is 1%, that is 36 kilogram per meter cube. Then volume of the material, cement volume, fly ash volume, water volume, basic gravity, that superplasticizer volume, everything, air, everything is fixed. Sum of all the above, it comes around 0.31 meter cube. And the remaining thing is the core aggregates. So this is total aggregate. So here assume the coarse aggregate as 20%. Coarse aggregate value as 62%, whereas then again this volume of the coarse aggregate and volume of fine aggregate is calculated. Here some corrections are required as per the code. Do not follow the exact procedure, but slightly some modification. So overall, then check is there that if you add everything, it should come nearly 2,400 kilogram per meter cube. So this is the final summary. So again, you can, since ChatGPT is quite easy, so ChatGPT or Gemini, whatever it may be, it's easy to write the optimized mix design. That's what I want to say here. This is how the AI tools are useful. To understand the AI tools, basics are very, very important. Otherwise, you cannot find the mistakes in the ChatGPT or Gemini or whatever it may be. So with this, I conclude my session here. Are there any doubts? Now the forum is open. If you ask, if you want to have any doubts, you can type your comment also.
Good evening, sir.
Good evening, sir.
Sir, shall we use the AI contents or AI's descriptions in our research?
Why not? Definitely. But you have to cross check it. sometimes it gives very blunderly wrong answers. Depends on the it's a calculator actually. Once upon a time calculator was there, then Excel replaced the calculator, then MATLAB replaced the Excel, then now AI replaced the everything. Rather than AI,
Yes, sir.
any
Yes,
other.
sir. Yes, sir.
Yes.
We have a lot of sophistication in AI. At the same time, we have much fear in executing the, things in our research.
Definitely, there will be a lot of mistakes will be there. We should concepts are very important. So that's why today I gave the lecture. First concept, then a tool description. That's what both are very important. AI tools are nowadays easy to arrive the conclusion, but the concepts are essential to decide whether it is correct or not. Rather than AI, any other tools for optimizing mix design for dense particle packing. See, dense particle packing means you're tentatively telling that it is high strength concrete. So high strength concrete needs very high dense packing is required. Actually, AI can assist you, but it cannot replace you. So AI tools will help you to arrive the mixed proportions based on your calculations. The formulas, everything you have to give. If you don't give, it takes the highest score. So we are in our lab in applied civil engineering group. We have developed one software exclusively for mixed design. For research purpose, we are covering multiple areas like self-compacting concrete, then pervious concrete, and drying concrete, and many other topics. And we are trying to give a comprehensive mixed design software which can able to, but it cannot do optimization. But it can give, it will do optimization, but based on the this that is the numbers you cannot able to trust. So for that, experiments are essential.
Sir,
Any
any
other
other
question? Yes,
question?
yes.
Sir, participants, any other questions, sir? Sir, it's okay, sir. Okay, sir. Very much thank you, sir. It is a very truly wonderful to have you with us today, sir. We especially grateful for your valuable ideas and knowledge you shared with us. Thank you very much, sir. We sincerely thank you for your time and inspiring presence. Thank you very much, sir.
Thank you, sir. Thank you for organizing such a wonderful event. So this is definitely it will be useful for the PhD scholars and faculties for doing consultancy services. Yes, sir.
Yes, yes, sir.
Thank,
Sure, sir.
thank you.
Thank you very much, sir. Dear participants, the next session will continue after a short break of over 5 to 10 minutes. Okay. Thank you, sir. Thank you, participants.
Thank you, Professor.
Sometimes even chemicals. So let us see about this in our seminar. In this seminar, I will explain where our water comes from, what property water has, what are the problems water can cause, and how water can spread many diseases. By the end, I hope you will all look at just a glass of water in a new way, not just as a simple drink. Let's go into our today's session. Sources of water. Basically, there are two sources of water. It is groundwater and surface water. Groundwater is the water that comes from deep underground, like wells and springs. It comes from the rain through soil and rocks. It is usually more clearer, than surface water. It is the water from rivers, streams, ponds. This water is usually polluted due to industry, sewage, human activity, etc. There is another category, groundwater under the direct influence of surface water. We know that groundwater is influenced by surface water. If we pollute the surface water, then groundwater also gets polluted. Water. It is the universal solvent. As we know, water is not just water. It contains many solids, gases, and even living things. Water is called the universal solvent because it can dissolve almost anything. This is useful for our life. For example, the food we eat dissolves in water, and our body gives us energy. But this is also dangerous in some other ways. We all know because water can be harmful if it contains harmful substances like nitrates, lead, which is also dissolved in water, making it unsafe to drink. We are also polluting the water that cannot be used for us in the future. Water has many characteristics. It can be physical character, chemical character, or biological character. Physical characters of water. We all know about this. I don't want to drag about this much, but physical character, water can be, it is the basic need for everyone. It hides germs, reduces the effect of disinfection. It doesn't have any taste, but it can also taste sometime and smell. Chemical characteristics. It contains large amount of chemicals and minerals that we need in our day-to-day life, like calcium, magnesium, and sulfide. It is all necessary in our life. Biological characters. Many many microorganisms are living in water. We can't see it in our naked eye, but it lives in the water. These can be both good and bad to our life, but it is important to drink water. Turbidity. Turbidity means cloudness of water. It hides germs. Red. It contains many germs, especially. It has solids and colloids in it. Due to this turbidity, there are many problems that are occurring, like taste, odor. We can observe this in our day-to-day life. If we taste a different type in water, then we can say that it is being polluted. Color. Due to some inorganic material or even organic material, there are color changes in water. It shows that there are many pollutants in the water which is very harmful, so that we need to do it treatment immediately so that we can consume it and be useful in our day-to-day life. Water has many minerals that is good to our body. It contains iron, manganese, fluoride, chloride, hydrogen sulfide, magnesium, etc. It has more than lot of minerals that our body needs right now. So drinking a lot of water daily helps us to grow better and healthy. This is all This is also, I told already, like it contains many chemical, biological, physical, and turbidity. It has many decaying animals, sediments, industrial and commercial effluents like sewage treatment, or even the rain, or even the pollution we put in day to day life. pH. pH is used to determine whether it is acid, neutral, or basic. It is used to determine whether we can use it or not. Hardness of a water. Hardness. Hardness means how much amount of calcium or magnesium that is present in the water. When there is hard water, it requires a lot of soap to get any microorganisms. These are the major problems that are associated with water. Calcium carbonate. We all have seen that calcium carbonate are built up in pipes and plumbing fixtures. It causes a major problem in our life, right? It can stop water flow or even reduce the flow. So it is also a cause. It is due to the hardness of the water as it contains more amount of calcium and other minerals. If there is no hardness in the water, these problems would not occur. Corrosivity. Corrosivity means when a water dissolves metals like lead and copper from pipes, it becomes poisonous. Corrosive water can bring metals into solution such as lead and copper. Corrosive, we can identify corrosive water with its pH, hardness, temperature, etc. Iron and manganese. These both are present in our water. It causes stains on clothes and toilets and makes water taste bad. We can identify it through brownish, blackish color stains. Iron and manganese are considered waste constituents in water. They can cause some odor problems. Removal methods of iron and manganese. It can be removed through aeration, supplying continuous air to the water and removing the iron and manganese. Ion exchange, adding some other ions and removing it. There are many ways to remove it. Dissolved gases. These all gases, we know exactly what they are present and how much amount they are present. Oxygen, it is bubbles in water. Water is not a water if it doesn't contain oxygen. It contains also carbon dioxide and a little amount of methane, hydrogen sulfide, etc. Biological character of water. Water contains many, many, many microorganisms. We can't see it on naked eye. It is due to which we heat the water sometimes. But it can be drink, but it should be purified before drinking. We can't drink a water directly from a beach, or we can't drink directly from rivers, ponds, etc. Like, right. So we need to purify that water because of these microorganisms. These can be disease causing organisms also, like pathogens. Waterborne pathogens, especially these bacteria, protozoans, viruses, etc. Bacteria are like E. coli. These causes diseases like typhoid, cholera, and protozoans. It also causes many, many, many diseases in our life. Viruses are the smallest, but it is the most dangerous things to our life. It causes polio, hepatitis, etc. Bacteria, typhoid fever. This is a major fever that are occurring in day-to-day's life. And some other diseases like cholera, tetanus, etc. are affecting our life, not for everyone, but for some amount of people who are affected by these kind of water. When they drink unwanted, polluted water, they are more prone to attacked by these diseases. Protozoans, these are also very small. They release some materials that are very harmful to our life, that makes several diseases to us. Virus is usually they cannot live without a host. When it lives without a host, it is not alive. But when it comes in contact with the host, it transforms into a whole new other thing, like poliovirus. Recently we have also seen many viruses. These are not only due to water, but many viruses are due to water also. These are very difficult to destroy. We can't just destroy with some injections or just some tablets. These are very difficult to destroy. So we need to really treat the water before we drink, or even before we use. Not only drinking water, our usage water should also be treated to a some extent, so that most of the viruses and germs cannot come in contact with us. Viruses, these cause chickenpox, polio, hepatitis, etc. Many diseases. It cannot be cured. Most of the virus causing diseases cannot be cured. Our government has introduced a drinking water protection program, in which the drinking water should be protected and should be purified, without which it cannot be provided to all other human beings. Though these factors that affect the source of water quality also causes many harmful. So the government has decided to protect the water and treat it, so that no, as we are facing many viruses and diseases due to water, our government has taken these steps to ensure that no one is getting affected. Due to these programs, many of the waterborne diseases are getting reduced in our society. Protective measures. This is also one of which that I am telling you right now. Educating people. Educating means not only just saying about what it is, it is also conveying the message that what you should do and what you should not do. You should get a clear clarification about these things. You should also educate some other people so that they won't misuse these waters. Wells. In rural areas, this is the most important source of water, which is well. Well is being used to take water in rural areas. In today's situation, also in rural areas, there are many wells, but nowadays wells are being decreased in usage as there are many pipe waters, motors, etc. Wells is being reduced. Usage of wells is reduced, but this is not a good instance. Okay. To make wells from pollu- to protect wells from pollutants, you should clean your well house. You should clean your house. You should not leave any. You should not leave any water unwanted, because as it can increase the waterborne disease, waterborne organisms, and especially mosquitoes, etc. Keeping wells covered, clean, and away from chemicals. It can be stopping sewage, boating waste, and industries from polluting rivers and lakes. Even small steps like fencing water sources or not parking vehicles near wells make a such big difference. There are many types of wells: dug, driven, drilled, etc. A well has many parts. A well has many parts: pump, sanitary seal, screen. If the sanitary screen, if the sanitary seal is not proper, germs and chemicals can enter directly into the water, which of course affects us when we use the well water. Abandoned wells are very, very dangerous because they act like open pipes that allow pollution to enter underground water. That's why special procedures are used to close them safely. As you can see, these are the many wells and water resources that we see in day to day life. Okay, guys, we often take water from for granted. We open the tap and drink without thinking. But as we saw today, water is just not H2O. It carries minerals, gases, germs, and even dangerous chemicals. Clean and safe water does not come naturally. It requires science, technology, and production. If we do not take care of the water today, we will not have safe drinking water tomorrow. So let us all remember this: safe water means safe health. Protecting water is just protecting your life. That's all. We are concluding this session. Sir, session has been over. That's all for today.
Ma'am, thank you, ma'am, for your wonderful presentation. Sir, any questions, sir? Sir, okay, sir. Sir, okay, okay, Jayaprakash, sir, for your sharing your very well knowledge,
okay.
sir.
Okay.
Thank you, sir.
Thank you,
very
sir.
much. Thank you, sir.
Thank you, sir.
Participate in the link will be shared in the chat box. The second session feedback and attendance sheet will be shared now.
Okay, sir.
Thank you, JP sir. Thank you very much, sir.
Thank you, sir. Thanks, sir. Thanks, sir. Ramesh, sir. Thank you, sir. Thanks, sir.
Thank you, sir.